Hey, so today I'm going to be discussing the lecture I attended, which was exploring the 2024 Nobel Prize in Physics, which was awarded to John Hopfield and Geoffrey Hinton for their pioneering work in neural networks. And so their discoveries are like the backbone of modern machine learning, kind of, I'd say. And so I'll talk about what makes it kind of revolutionary. So John Hopfield's contribution, so it was like imagine a network of nodes, right? And they're like pixels in an image. So he pretty much invented a way for this network to save and recreate those patterns, like storing a picture in memory. So each node is like connected to others, and the connections are like tiny switches that interact. And so the physics behind it is really cool, in my opinion, and it's based on how atomic spins or like tiny magnets in the material interact. And so the entire network pretty much behaves like a spin system, minimizing its energy to find like the best version, the clearest version of the image that it was like trained on. And so when the network's like fed an incomplete or distorted image, it kind of just like adjusts its nodes to lower its energy little by little until it recreates the stored image. And so the process was like completely new to me. I found it pretty cool because I really hadn't realized like how much the neural networks owe to like physics. And so what I did know before the lecture was that the neural networks were like somehow going to be important to how AI functions. But this lecture kind of like connected those dots in my eyes between like the physics of spin systems and machine learning. And so it's kind of like cool how a concept from material science led to the creation of like some of modern AI, I'd say. But when we go to Hinton's work, pretty much Hinton's work was building on Hopfield's network. And so he introduced the Boltzmann machine. And so this network pretty much learned by recognizing patterns in the data. Unlike Hopfield's method, it used tools from statistical physics in order to like train itself. So if you gave the machine something like an image of a cat, over time it would learn what makes a cat so that it can classify different images or even like produce new cat images. And so what really like sparked my curiosity here was the elegance of using physics concepts really to just power something futuristic and like AI, which I wasn't expecting to be really intertwined. So like I've looked into machine learning basics, but like I didn't really understand it too much. But seeing how the physics principles like underpin the entire field gave me a different perspective. And so it kind of relates to my area of study because for someone like interested in engineering, I'm thinking about how like foundational science kind of like translates to like new technology. And so this lecture just made me realize how interconnected different disciplines within like STEM can be. And so after the lecture, I kind of dove and did like a small amount of research. And so I found a couple of papers on like Hopfield and Hinton's methods and like kind of like just looked at general applications nowadays for like image recognition and generative AI, which is pretty cool. And yeah, I mean, it's exciting just because like these networks, I guess, that they kind of like came up with are inspiring advancements in like, I don't know, new computing systems that I think are going to be more like efficient. And so pretty much just like to wrap it up, the Nobel Prize is really awesome and kind of just like shows the spark of the AI revolution. And I think it's like a testament to what we can do with foundational science. And I think it's pretty inspirational. So yeah, it's cool.